Hello, my name is Karthiban and my register number is URK23A1014. Now I am going to explain the experiment number 1, which is MNIST and fashion MNIST data. First, we need to import the necessary libraries: TensorFlow and Keras for building and training the deep learning model, Matplotlib.pyplot for visualizing images, next NumPy for numerical operations. Next, we need to load the MNIST data, which contains 70,000 grayscale images, which is 60,000 for training and 10,000 for testing. Next is to pre-process the data, which is used to normalize the pixel values of the image uh, to the range of 0 to 1 by divide by 255, which helps the neural network train faster and perform better. Next, building the neural network model. First, I create a sequential model with following layers, which is convolution layer, which has 32 filters and a 3 caustic kernel, and, and followed by a max pooling 2D layer, which reduces overfitting, and again a convolution 2D layer with 64 filters for deep feature extraction, and finally a dense output layer with 10 neurons and a softmax after injection. Next, to compile the model, I train the model for 5 epochs with a batch size of 64 using a fit function. Next, to evaluate the model performance, how well the model performs on a unseen data. Next, to make prediction visualizations. Let's see the output. This is the predicted and the actual output. Next, the fashion MNIST data. First, we need to separate the X train and the Y train, and then we are seeing the shape of the data, which is 70,000 grayscale images, which is 60,000 for training and 10,000 for testing. Next comes the data pre-processing, which is original ranges from 0 to 255. So I normalize the values by dividing it by 255 to make all values fall between 0 and 1. Next, I flatten each images into 28 plus 28. Next, I was creating a model first in a sequential layer model. The first layer is the dense layer, which has 128 neurons with a ReLU activation that act as a hidden layer that learns patterns and features from the input data. Next comes the dense layer with 10 neurons and softmax activation function. Next is to compile the model, which I use optimized as Adam, and followed by a matrix, which I use accuracy. Next, I was training the model with 10 epochs with a batch size of 32. Next, I was evaluating the model with the unseen data, which I got 88%. Next, I make predictions and visualize the final output, which is the output. Thank you.